maybe let's oh, it is absolutely. Yeah. Okay, well, I'm talking for about 10, so that only gives us about 5. Yeah, okay, but you're the ones who will be saying how to do this. Okay. And will it be more answering questions? Your call. Your call. Okay, I'm fine. Again, I don't want this to be all wants this. This is definitely chairs are trying to figure out how to do this. Okay. Well, no. Yeah. See that kind of thing. Yeah. I will share.
No, I need to go in the musical first.
It's time. Well, or maybe. I mean, so yeah. Shall I open? Do you want to open?
There. Okay, cool. Actually, even then this.
Yeah.
Hold on, it's okay. Which one? The clock, countdown clock. Click on that. Then you can enter a time, and it will show up down the bottom there. And that way people have a
Yep.
time thing.
Okay.
Go ahead. You want to go ahead?
Yeah, it's fine. Yeah. Okay. Yeah.
All right. Good morning and welcome to the folks in the room. Good morning, good afternoon, good evening, wherever you are, to the folks on remote. This is DNSOP at IETF 115. And we should probably go ahead and get started.
Okay. Hello, welcome, working group. Well, Tim is remote, but he sent his regards, of course, and he will be presenting the document update.
He
And this
also
is
sent a cute picture of his dog.
exactly. We can't. It's a good tradition here. The chairs, myself, Suzanne, Tim, our area director, Warren, he's here in the room. The chat room, we have, of course, the Jabber room, but also integrated in the Meet Echo and Zulip. So there are the links and the reference. The minutes, Paul, maybe, yeah, and Tim will be back up or vice versa. So Tim will also take notes together. Thanks. Okay, so we're an IETF working group. So the note well applies here. Everything you contribute, mentioned at the microphone, will be recorded as part of the the note well applies to your work and your contributions. So we expect that you're aware of the note well. Part of the note well is the IETF conduct, code of conduct. Well, there are 6 points here mentioned. Summary: be respectful to each other. If you think code of conduct is violated, please reach out to the DNSOP chairs. The meeting tips: we are a hybrid meeting, so everybody in the room is asked also to register via the Meet Echo Lite client. You can scan the quad code or just use the full client. Also, we are asked, or it's ITF policy here at the ITF 115 to wear mask at any time except for the presenters here are allowed to take off their mask. Other things, especially for the people in the room, the on-site, if you want to go to the mic queue, use the Meet Echo Lite app or the Meet Echo app, raise your hand, and then you are asked to come over to the microphone. So it's equal for the remote participants. Good. We go now to the agenda. We just had the blue sheets, the note well. Tim will give us an update of ongoing work. The hackathon update, traditionally part of the chair slide, is now moved to current working group business. So there will be an update of the hackathon, but not here now, but in the regular agenda. After the working group business, the current working group business, we have for consideration and time permitting presentations. The agenda is also published on Data Tracker. Good. Tim, can I ask you to give the document updates?
Yes. Yeah. Good morning, all, and thanks for being here. So we'll kind of go through this because I know we have some busy stuff. As you know, in the ISGQ 5933 biz, which is scheduled for the teletracker, I believe in December, and catalog zones, which has warrants as the action, but I think they need an update from the authors. So authors, I know you're there. You may have to step up a little bit and do that, but everything else is moving along for those. Void fragmentation has been approved, and Ben and I are going to work on the write-up on that, and we'll sort of chase that down here very shortly. So next slide. Things are moving along on some of this. Of course, in the editor queue, service B, I think it's going to go for a record and sort of sitting, and the DNSSEC BCP, which is in there too, which it looks like it's been moving pretty fast. So thanks for all for sort of chewing on that. So next slide. We've got a bunch that are kind of. So we have one working group last call. The DNSSEC validator requirement.
Tim?
Yep. Go ahead. Can you hear me?
The audio was started quite well, but it becomes worse and worse.
Oh, I was afraid of that.
We
So
can.
it's getting worse. So Benno sounds fine. Maybe Benno. If it's not staying well, then may want to jump.
I can continue.
Yeah.
Tim,
Yeah.
do you hear me?
Yes, I do.
I can finish the document update because for some reason the audio becomes worse and worse.
How I turned it off and back on. Is that better?
Oh, much better. Thank you.
Interesting. Thanks, Wes.
You're sitting beside me almost, so it's excellent.
My big comment here on validator requirements is we need more comments from the working group to sort of move these documents along, and so we get stuck, and so the three of us have to go chase down reviewers or people to sort of thumbs up, thumbs down. Is there anybody in the room that's against moving this to working group last call? Please speak up, or we'll consider that the working group last call approval, and we can move on from there. I know we have one comment from Brian that needs to be addressed, and we will get that addressed from Daniel. And part of the reason we're stuck moving documents along is we need more help from the working group on that.
Yeah, Tim?
Yes.
Tim, your sound
It's gone back
is breaking up again. We can
So
go ahead and finish.
that was all really the comment. I'd like to just get more folks on the working group last call to sort of help us get those things moving along. And I'll kick over to Benno then. And I apologize. Meet Echo seems to be hating me this morning.
Thank you, Tim. Okay.
Benno.
Oh, sorry.
Jeff Houston,
Yeah.
responding to the previous slide, please.
Yes.
I think it's pretty sad that we're moving a document into working group last call with only one comment. And
Yeah.
the thing that's kind of changed is, of course, there's now a DNS directorate, and as chairs, I believe you have the ability to actually request an early review by a member of the directorate. And so one of the ways to actually resolve this is, rather than go, oh, working group last call, even though no one has read it, evidently, is to actually throw it at the directorate at this point and ask for an early review to see if it should proceed. Just a thought.
Thank you, Jeff.
Yeah, thank you, Jeff. That's actually really helpful to have the reminder that the ADs have spun up the DNS directorate, and that is another resource we have as far as managing our documents. Thank you.
I agree, Jeff. Yep, I agree. And Jeff, why don't we give you the action item of asking for a review of this one. How's that? You're now in charge.
This is Jeff. I can assign a reviewer, but I can't assign a document for review. I don't have that magic power in the data tracker. I think chairs or someone can do that bit of kerfuffle.
It's an area director thing. So, and I'm sure there's an area director there who's qualified to push those buttons.
We will sort the buttons. We'll sort the buttons offline. Thanks.
Okay. Oh. So other current working group documents. We think, and the authors think, is close to working group last call. So not in any specific order here. We see GLUE is not optional. The RFC 8499 BIS. There's now discussion on two terminology. So the bailiwick. I think that discussion is bailiwick to historical is, well, had some replies, but especially defining GLUE does see some discussion. Very good, thank you. So we need to take this discussion further to the mailing list, preferably finishing up in 1 or 2, 3 weeks, but limited, and then we can make forward progress with both documents. LTLD will be presented in a minute or in 5 minutes. DNS zone version, the authors think they incorporated all the feedback from the mailing list. They think it's ready for working group last call. We will schedule it, and please have a second look at the document and give feedback on the mailing list. And DNS error reporting made good progress and will be presented later this session. So we're making good progress overall. We just had a meeting with the author of DNSSEC. No, sorry. DNSSEC bootstrapping. I think the author also think it's ready for working group last call. They incorporated a number of the feedback from the working group. There was some discussion. So we also probably want to make progress here. I will discuss it also with the author. And as revalidation, there will be some other authors helping with the document because one of the authors has another job and other priorities. Right. More work, DNSSEC automation, that one. There will also be another author or authors be added to the document. It's in good shape, maybe another revision, and we'll also ask for a working group last call from the working group. The domain verification techniques will be presented and updated if time permitting. It's put on the agenda yesterday. And caching resolution failures will be presented. So all in all, yeah, we're making good progress with the documents. They're either close to working group call or making good progress. So thank you. And just adopted SVCB Dane. No, well, I will skip these slides. These are possible candidates for adoption, new work in the working group. I will reach out to some of the document authors because they didn't have much attention on the mailing list yet, but there's be continuous development and updates of the document. So it should get more attention of the working group, or by the working group. Good. All our work is also on Data Tracker, of course, and on GitHub. So check the links if you want to get the latest updates or interact with us or with the authors. This agenda, okay. Well, this is the current agenda for the current working group. Yeah, I will go over the slides. It's not so for consideration. We have 3 presentations, and if time permitting, other work has priority. But if time permitting, we have these 2 presentations at the very end of the session. We can start. Let's get started.
Yes,
I will load the next slides. So you do the introductions.
Sure. Go ahead.
Yeah.
I do kind of need this one.
Okay. Oh, sorry. This is
Next one.
right. Yeah. There we go.
Yeah, so we had a lot of discussion on the mailing list, both on the process and the substance around the LTLD draft. And the goal today, we're giving it a strictly limited time and a strictly limited scope. But Paul has very graciously agreed to come up and speak to, are there open issues that will benefit from further discussion? The chairs and editors have discussed what seem to be contentious issues. The chairs posted some concerns on the list that I believe, have been addressed in the current draft. If it seems we do have open issues that could be closed by further discussion, we'll schedule an interim or some other way of dealing with those. But if it seems we've said everything and views are not likely to change further, we will move to working group last call. Thanks everybody for your patience, and we are getting this draft towards resolution of one kind or another. So Paul, if you wouldn't.
Just a very quick note, Rob
thank you.
Wilton, who's sitting over there, is the responsible AD for this, not me.
Because Warren is a co-editor, the rules we all operate under mean that he can't be also the AD that oversees its movement in the process. So thanks for that reminder, Warren.
So given that, I'm going to do a mediumly brief presentation. Chairs are going to run a mic line if there are people who want to say things that haven't been said on the list or are new and such. And a new deck is being shared.
Yeah. Indeed. Give me 1 minute because I can't find it now.
Are we having a
I'm
Medico moment?
It's overwritten. Sorry. Excuses. I already checked everything, but
Victor. I see Victor in the queue. Victor, would you?
Victor, are you going to proceed this?
I'll do these slides. I don't know. It's in the data tracker, but it's not on Meet Echo.
Did you click the refresh?
Probably I need to refresh. Okay.
Yeah.
Oh, I updated the slides this morning.
Yeah, I
Right,
uploaded
okay,
them
yeah.
also, but I
Right.
will do it.
Am I on?
You are on, Victor.
Yes.
Okay.
But what kind of slides?
So, right. So if there's a quick slot, the similar somewhat .home TLD has a few hints for validators to try and reduce leakage of traffic. I was wondering whether anything like that should be said for .alt, like, returning, proof of non-existence of DS while not sending any other queries.
So I'll sort of cover that, but since alt is not going to be in the root zone, that doesn't seem possible to do.
You can still return proof of non-existence of the whole domain, which includes proof of non-existence of its DS. So seems to work.
I'm not
NX domain proof.
sure how you would do that for a zone that doesn't exist. Maybe send that to the list.
The NSEC records prove its non-existence. That's the NSEC for you.
Beat me, but maybe someone else can try.
You want?
Right.
Do you want me to share it?
Yeah,
Yeah.
please, because
Hopefully it works. Right.
Oh, wow. We're letting Warren take over.
Well, the problem is that it's listed in the manifest, but does not appear to actually be
it's in
there.
data tracker, but in the Meet Echo IDC, twice the chair slide.
Somebody has to actually grant me sharing.
Oh, you need to grant Warren
Maybe.
shareability.
Yes. You should have it now. This is very weird.
See the whole chair slides.
Yeah, same for me.
Yes.
I will log out and log in, maybe. And
No,
apologies
that's-
to the
Are
web.
those the ones? No.
Oh, no, that's Suzanne's. Oh, it might have been that two things were named similarly, but shouldn't be.
Similarly, but not this. No.
Right.
Okay. All right. The other thing we could do is go on to the next agenda item and figure it out.
Permission again?
Warren wants permission again.
Oh,
Can I give permission?
I did. You should have it.
We're looking at Warren's slides now and it's still saying shared. So,
Yeah, I'm looking. I don't see them in this list. I see them in the other list.
okay.
So I guess move on. I'll ask Midako.
Yep. Okay. Thank you.
Thank you, Paul.
That went more easily than I thought it would.
Wow, this is new on me. With apologies.
So for
Roy was next.
some reason they're not actually showing.
Yes. Actually, if Roy Aarons is in here.
Yes, but I will.
Oh, you were doing, okay.
Yeah, Yeah, so actually, DNS error reporting will be the next slide set, and also hackathon results, because DNS error reporting was a major topic at what we worked on during the hackathon. There were 5 in-person persons working on it and 1 remote. And yeah, so Roy asked me, but there were also some other projects worked on. So Roy said, why don't you present those other 2? And then I'll do the hackathon results for DNS error reporting. I'm going to take this off. So next slide, yes. So indeed, one of the projects was working on NetDNS Resolver Unbound. So NetDNS is a Perl DNS library, worked on primarily by Dick Franks. And Dick told me once, if it's nice weather, he goes out, plays golf. And if it's rainy, then he works on NetDNS. And he lives in London, so it rains quite often. And but NetDNS is actually an early adopter of many of the standards that are drafted in DNSOP. So worthwhile to look at if you want to compare it with your own implementation or to see how it's how your draft is implemented. So we worked on bindings for NetDNS with lib unbound, and that involved adding some new functions to lib unbound to send packets directly. So this is not quite finished, but is coming. Next slide, please. And the other interesting hack we did, besides DNS error reporting, is implementation of handling of encrypted client hello in a proof of concept library called Connect by Name. So the server name indications is one of the holes in the leaky privacy boat that leaks the name to which TLS session is set up, and encrypted client hello is the solution to make that private as well. So we have this proof of concept library that sets up connections and under the hood does everything what is good, right? Happy eyeballs, Dane, you can specify policies to say, I want all the DNS lookups to be opportunistically private or authenticated private. And yeah, so Philip Homburg worked on that. For the library, looking up SVCB and HTTPS records and using the encrypted client hello configuration parameter to set up the encrypted client hello with this one server we know that supports it, which is default.io. And Philip will also later in this session talk about the policy option that is also part or came out of the Connect by Name project. And next slide, please. So yeah, we had a really good time. So I think it's also for other people working on drafts good to participate in the hackathon, if not for the in-person or the direct feedback on your drafts, then for the food, because it was amazing. And we also learned that DNS error reporting rocks. Next slide. So these are all the people that worked on it. I see there's one name missing. We also had a remote participant, Tom Capet. Next slide, Roy is going to take over to talk about DNS error reporting.
Thank you, sorry. Thanks, Willem. I'm Roy Adams. I'm one of the two authors for DNS error reporting. Where are we? Just a small introduction. DNS error reporting builds upon extended DNS errors. It reports to the operator of an authoritative domain instead of reporting back to the client. That's what RC8914 is used for to begin with. The resolver, we had a small change. I will get to that in a minute. The resolver now indicates support for reporting. The authoritative server then sends an agent domain in an EDNS 0 option. Sorry, I'll take this off. EDNS 0 option alongside a regular response. And then the resolver sends errors to the report receiving agent formatted as a DNS query. It's pretty straightforward. We've seen it working during the hackathon. Also during the hackathon, folks were so enthusiastic that we immediately thought, how can we improve this? How can we make this more efficient? Next slide, please. One thing to make it more efficient, so instead of using the queue type null to send a report, you want something back that you can cache. Initially, we just had no error or NX domain caching. NX domain caching is a problem because you will cut off the entire string for the entire domain for that. But if you have a text record, if you just query using a text record, then you can tailor a response. So you can basically send a specific text record back with a TTL that is tailored so it can dampen the query load accordingly. Now we also have that the resolver must indicate support. So what we used to have is that you just spam with unsolicited EDNS 0 option in a response every time, always. The reason we changed that is not because it's frowned upon to just include unsolicited EDNS options. The reason for that is to avoid later on cascading error reports over error reports over error reports. So we changed that. Another thing we changed, and this is a small optimization, but it's really, really handy. So in the formatted query, you used to have the extended DNS error as a label before the domain name that was broken. It's easier to have it after the domain name. So before the underscore error, if you have read the draft. And the reason for that, you have now the error code in a consistent place always. It doesn't change depending on the domain name length, depending on the domain name that's broken. All right, next slide, please. We have a few implementations. I'll list them quickly. Willem, who was just up here in Unbound, you can actually test it now by going to these open testing resolvers. Next slide, please. We have Stefan Botsmeijer. Stefan had an implementation. He's named that Drink. I hope it's an acronym. Otherwise, it's a really funny one. It's an authoritative server, easily adjustable for experimentation, etc., works as well. It does do both EDNS signaling and the report processing. So this is basically the next step. Once you receive the reports, you can now process them and do something about it. Next slide, please. Shane was there as well. Shane worked on a proprietary authoritative server called Trex. This is NS1's proprietary server. He mentioned it was straightforward on the authoritative side, and you can configure unique report receiving agent per server. Next slide, please. Mark Andrews submitted a ticket for bind 9. I'm just going to leave it at that. I'll leave it to Mark to come to the mic later on to explain what it means. I don't want to say they're going to implement it. It's basically a ticket that says, have a look at this draft and maybe implement it in the future. Tom Carpe from home. I apologize, I didn't list him in the initial slide with all the people at the desk, at the table. Tom Carpe worked on an LDNS version, a development branch version for LDNS, and LDNS TestNS, sorry, can now easily be used to fake an error reporting support authoritative server. Next slide, please. Oh yeah, this is what I wanted to make clear. So version 03, we thought it was stable enough. After some experimenting, we made some optimizations, not super major changes, but some optimizations. So after -04 comes out, I haven't submitted it yet. After that comes out, we'll give it a few days, a few weeks to let people read it, and then we will ask the working group chairs to consider a working group last call. All right. If you have any questions or suggestions, there's of course the mailing list, dnsop@ietf.org. It's not really useful to mail me personally. I'll do my best, but what I've noticed is that your questions often are relevant to the entire working group. So I've got a fair amount of feedback that's now in the draft, better wording, etc., But send your questions and suggestions to the mailing list. That's it. Thank you.
Thank you. We have one question from Victor. Victor, please go ahead.
Should any language appear in the draft about validators behind forwarders? They aren't directly talking to the auth, so they can't see these extensions.
So thank you, Victor. I think the question is related to the problem of cascading errors. When a reporting resolver forwards the broken error query in order to get it reported to a forwarder, the forwarder might then do might do error reporting as well, and then you get cascading error reports. Now, one idea is to make sure that when a domain starts with _ER, then don't send this option in the query that you send out. So don't send the EDNS option in queries about error reports. That's one way to do it. The other way to do it, that if you're a forwarder, are you actually doing error detection, right? I mean, that's the question with the forwarder. If you do error detection, then you basically need to implement the draft accordingly. So I will add some language into the document, basically regarding forwarders, or basically clients that may not do error reporting, that may set the reporting option. Thank you, Victor.
Thank you, Roy. Okay. Up next.
Yeah, it looks like we have the slide issue fixed. If you're ready to try again, Paul. Thanks for your patience.
I see slides. Cool.
also set the time.
Next slide. Okay, so some people have been asking, what is the status of the draft? The actual status, oh, I can do this, is held by working group. Warren and I, the co-authors, asked for a working group last call. Chairs asked for changes. We did those. The chair seemed to have accepted those changes. There's a new draft now. And then once that newest draft came out, a whole bunch of discussion happened. I'm going to be covering the discussion here. But basically, the status is we're still held by WG. The chairs are still trying to decide about working, moving it into working group last call. So it's still just a draft. Next. There are two top issues, and I think probably two of the only issues that really matter here. This is the first one. I've got 2 slides on this, and I've got 2 slides on the second issue. So basically, we have this text which says what resolvers should do when it comes to .alt. And the current text basically says, treat it like anything else. It's not special. Some people on the list want to make it special. That is, they want to put text in this document that say resolvers should or must do something here. And the difference being that if the text says a resolver should or must be doing something, then the hope is that resolver vendors will read the draft and go, oh, I'm supposed to do something with this and do it. Next slide. So the reason for putting in a must or should is to get resolver implementations to not send things to the root. So that's the only reason to do it is to have an effect. The desired effect is fewer queries will go to the root because they'll just get swallowed by the resolver itself. And that has been shown to work in the past. .onion, whatever the RFC that created .onion, says resolvers should not send these on, and some resolvers don't. Some resolver implementations don't, and some resolver implementations ignored that, and they do pass it on. And their root server operator sitting in the room, they can look at how many .onion queries they get and such. So it's definitely not 0. But if you look in the code for some of the resolvers, they swallow .onion.
Paul,
Yep.
do you want to take questions now? There's one in the queue, or
This is
Or what you-
totally your call. And let me at least finish the slide.
yeah.
Okay, but then if you would like me to take questions here, that's fine. But since we know not all resolver software, I'm sorry, Wes, what are you saying?
Keep going.
Thank you.
Yeah, I
Okay,
think for
sorry.
time
Then
management.
maybe take yourself out of the queue, or the benefit is for adding this code would be to the root servers. It does not help a resolver to have more code in it. More code can always cause more errors. It also doesn't hurt, as we know, because this is true for .onion. It's been true for years in a couple of the resolver software, and no one's had any problems. So really the question is, what do we want to do here about saying that a resolver software should or must do something? And then the last bullet here is the note, which is, this is an informational document, which is fine, but it's sort of weird for an informational document to tell all of the all the resolver vendors out there what they should or must do. So do you want to stop and do this one first, or go to the next one?
Go to
Okay,
the next one.
so okay, now we're switching topic. Next slide. This is the second major issue that came up on the list after we posted the last draft, which is some people said, oh no, we shouldn't be using the current design, which is just never allocate .alt in the root. We should allocate it and then have it point as a DNAME to AS112. We have RFCs on that. This was brought up 5 years ago when the document was in working group last called the first time. It wasn't accepted then, but now there's a discussion. Maybe we should really think of this now. The reason for doing this that was stated on the list and is backed up by data is that it seems like resolver implementations do better with a delegation at caching, the fact that it's delegated, than remembering that they have a negative answer in their cache. So as you can see, if you go to that link, Dwayne has a long presentation, but basically when they dropped in a delegation, the cache is kicked in much better. So this redesign would again not help the end users, but it would help reduce traffic going to the root servers. Next slide. So this is not an easy fix because, in fact, the whole point of this document has to date been this TLD will never appear in the root. So when we say to somebody, hey, please use this TLD, you're safe to use this TLD for all of your alternative stuff, they knew that anything that leaked would never pass the root servers. That is, they would come back with an NX domain. What doing AS112 says is we already have a set of authoritative servers that will then include this for, who always give back the right NX domain answer. But this means that to somebody who's writing something that might use this, they know that in fact it'll go to the root server and then go to some other server that's not controlled by them that they are relying on to send an NX domain. So that's a very different promise to the people who would be using the .alt domain. It would require new agreements with IANA, and some people said, oh, we can't do it because you can't put these in the root zone. You can make changes to what IANA does. It has to be, asked officially and stuff like that. But saying this will never happen is simply silly. The IETF gets to say what happens in the root zone on a technical level. So that's not an argument against it. But the basic argument against it is that this is a complete redesign. This is saying, instead of simply don't do this, we're going to design it this way. And then just as a side note, Warren and I have talked about this. If the working group wants to go for this, it needs to start as a completely new draft because a lot of the text in the document, it would be simply wrong. That is, a lot of the text in the document is assuming this is not going to be something in the root zone. And neither of us are interested in this. So if this is what the working group wants, you're going to have to find some new authors to do it. It's still doable. I'm not in favor of it, but I'm just one voice here. And that's the last slide. So then you guys run the mic line and you say when not, when to stop.
Yeah, there has been quite a lot of discussion on the list several times over, but the reason why we're doing this is so that everybody knows where the document stands now. And if there's anything you feel has not been said or needs to be said, and again, given where we're at and where we have been in the discussion, we do have a few minutes, but this is mostly sort of a status setting. Wes.
Thank you. Wes Herdeker, USC ISI. Not with my ICANN board hat, not with my AB hat, but with my root server operator hat, because
Yes.
I think that's the one you wanted, right?
Yes, exactly right. This is DNSOP after all.
This is DNSOP, yes.
Right.
So when I think about what should be done, so thank you for putting the document together in the first place. The right thing is don't send packets to the DNS that shouldn't go to the DNS, right? So
don't leak. Yeah.
Right, don't leak. And .alt is supposed to be the switch that says don't use it, weirdly enough, right? But it will happen. We know it will happen. I do see queries for .onion. I don't see a ton. I don't worry about the massive .alt queries because I don't see a massive amount that swamps us for .onion. That being said, don't do it. So my suggestion for the document is, do put in a statement saying resolvers shouldn't send this if possible.
So they should know about .alt and not send it.
Yeah, and I recognize that the code issue,
Sure.
but we already have a code issue for pre-existing stuff. And it's
And again,
sort of-
only I looked at all 4 of the common resolvers. Only 2 of them did have that code in it, but they already have the code in it. Looked like it was a way where they could extend the list of what they have.
And so one of the things I was going to add is we won't get 100% deployment, but the reality is we shouldn't saturate the DNS system with anything. So I don't really care about the root server system as much because there's a lot of them. I care more about the constrained lengths that, maybe actually these extra queries might actually, affect people way down the line or something like that. As far as it going into an informational document, it's still guidance.
Mhm.
I mean, the reality is that should and must are not enforceable in standards documents either, right?
Yes.
So, I don't have an issue with putting should and must kind of information in there.
Before you go off to the next one, do you have a preference here for should or must?
Again, does it really make a difference? They're either going to
No preference is
Yeah.
a perfectly good preference. Thanks.
I would say should because the system's going to operate without it, right? You're not
Right.
going to cause interoperability problems if it's a should.
Okay, great.
So,
Yep.
As far as 1112, yes, it probably needs to be a separate document. It could be done later. Again,
It can't be done later if this is already an RFC, because this one says shall never appear in the root zone.
we could, the other one could update this one to fix that statement.
That's a broken promise then. I would be very hesitant to be author of this document knowing that we intended to break the promise later. In fact, I can just say right now, I would take my name off this in a moment if I thought that we were going to break the promise made in this RFC later.
That is fair, but so why don't we take this offline, Paul, because
Okay.
the queue is already long, but,
Okay.
but we can fight about it.
Okay.
Yeah, the other thing to comment on that as far as the document status is that it's actually currently tagged as standards track, and I believe that's required by the registry
No, it's
policy.
informational, I believe.
Don't think so. Well,
Yeah.
what I was
And
going to
it's not,
say,
and that's not required. The requirement for 6761 is either standards track or ISG approval, which this would have ISG approval eventually.
that's something for the chairs and the AD to sort. Thanks.
And Somerset Liquid. I don't like the idea of AS112. It just seems like a hammer for what shouldn't actually really get to DNS in normal working operations. I do have a question though, and this might be better for the root operators. What do we perceive as the load increase of leakage of alt into the normal DNS space? I mean, how big of a problem is it actually in just leaving this out in the sense that if we don't even say should or must, what is the actual load impact and how much of a problem would that be if we had that leakage?
I'm not answering that one.
I can switch hats long enough to answer that one as in my, putting on the root server hat that Wes and I actually pass back and forth. The actual impact would be negligible. It's just a matter of, in general, what you get is there's an awful lot of stuff that goes to the roots that shouldn't.
Then we don't need to do anything really, in my view.
The roots are massively over provisioned is sort of the right statement there. That doesn't mean that we want the queries.
Exactly. Okay. So
Next is Elliot.
Hi there, Elliot Lear here. Okay, so a couple things. First, thanks Paul for taking on the work. Thanks Warren, and thanks chairs and working group for working through this. As the independent submissions editor, this came to me, as you saw, through the GNS work, and the GNS work depends on this work completing. And so again, I thank the working group for working on this. We've had a discussion about a second level registry. You pulled out the text there in the current version, only you sort of half did that. And there is still text in the draft that says that name systems should add a unique field to the left of .alt. And I'm going to channel Martin Schanzenbach, who's one of the users, said, do or do not. If we're not going to have a registry, then let's not have that convention either, would be his point. If we are going to have the registry, then let's have the registry.
Sure, absolutely. Send that to the list, especially with word changes. You're making it simpler. Thank you.
Okay, that's his point of view, and I'll just end with the third point, which is thank you again.
Okay. Well, again, Warren did all of the work up till 2 drafts ago, so.
Okay. Paul speaking as individual. I just want to say that I don't think the AS112 solution is very good because since it's not specified what could be on the left side of the alt part, it could be a 3,000 character string and we only allow 63 on valid DNS. So you're going to get form errors before it would be following the D name up the chain anyway. So I think that the AS112 will not catch the proper things, or it will catch things where it actually has to return form error instead of NX domain or something. So I think it's a really bad solution for this. It's like the wrong tool for this.
Okay, thanks.
Okay. Ben Schwartz?
Hi.
Okay.
Okay. So on queries to the root.
Please, I want to hear. Sorry,
On
go ahead.
On the topic of queries to the root, I think that the right answer here is to say that from the stub's perspective, a recursive resolver's behavior should not be visibly altered by this informational document. So while it's advantageous to the root for recursive resolvers to synthesize some responses locally for .alt, and I think that's a good thing. That synthesis should not result in a behavior change that's observable to the stub resolver. And so what that means, in my view, is that if we're going to talk about that kind of synthesis, we need to have some very special language about how to handle DNSSEC, because if I ask my resolver whether .alt exists, I'm asking whether .alt exists in the root, and I want a DNSSEC validated. I want the correct signed NSEC record to tell me there's no such thing, and that can't be synthesized locally. So I don't object to local synthesis in general, but I think that it's not straightforward to implement. At a minimum, the simplest way to do it is to just disable local synthesis if the DO bit is set, for example. Essentially, what we're saying is you're allowed to do local root, and since .alt will never be in the root, you're also allowed to do the special subset of local root where you only do local root for .alt, because we guarantee that that's never going to be in the root. But you can't just blindly synthesize NX domain responses because you can't sign them locally unless you are also basically doing local root.
Thanks.
Yeah, thanks, Ben.
Okay.
We did close the queue after Ben. For those
Okay,
of you
I want to
who-
make it just.
I'm sorry, go
I
ahead.
mean, I want to just make one last editorial comment that the draft constantly has adopted the terminology, the DNS context as the namespace anchored at the IANA root. I find this terminology very confusing because DNS is a protocol. It's a protocol that anybody can instantiate an instance of, not just IANA. And there are a bunch of alt roots that prior to this document have always, in my experience, been described as implementations of DNS, the protocol, just not the IANA root. So I just have trouble reading the document because of that.
Okay, if you can send suggested text on that, that would be helpful, I think, to everybody.
Right, thank you. And sorry to step on you, Ben. We had closed the queue after Ben, but Rob did get in the queue as the responsible AD, so I'm going to you get a special pass.
So Rob Wilton, just to say thanks to the working group for working on this. I know it's a sort of contentious topic and tricky, so I get it. I think we're close to rough consensus here, so I think we're making progress. So I think that's great. I'd also like to say I don't know anything about DNS, but I just want to make one comment as an individual in terms of the must or should statements. Is saying. Is it that the stub resolver shouldn't be sending this stuff on? Because obviously you should be filtering out at that stage. And if so, can we put the constraint on that and not the recursive resolvers? Is that one option? I don't know if that makes sense.
That's an option, but I think that the folks who wanted it for the recursives know that asking the stubs not to do something is sort of silly. You know, it's like saying to your dog, you know, don't do that. And the dog goes, great, I heard the do that part. Whereas recursive resolvers, we know, in fact, the resolver vendors actually do the right thing a lot. So I think that was more. We can also add it in for the stubs, but that's almost wasted text.
Okay, and I'll absolutely defer to the experts on this. And then the other point I want to make is in terms of the document status, I'm less so keen on the ISG approval thing. That could be slightly trickier. So is there a reason why this can't go through a standards track now? And if the ISG then says, actually, we want it to be informational, we'll downgrade it. Is that a problem?
That's up to the working group. I think the original reason for having it as informational is there's no protocol in this. Saying don't put something in the root server is not really a protocol thing. It could be standards track. It can be informational. Should not be experimental.
So my advice, I think standards track gives it a bit more weight as to, so I think that'd be my recommendation.
Okay, great. That's for the chairs, not for Warren and I.
Okay.
Okay, great. Thank you.
Thank you very much. And who is next up?
Thank you. And either the people that were queued and while the queue was locked, please send also your comments or your questions to the mailing list. Next up is Dwayne. Right, there we go.
All right, hello everyone. So I'm here to talk about the draft, which is about caching, negative caching of DNS resolution failures. This was last presented at IETF 113. Next slide, please. So as a quick reminder, there are some recursive name servers that seem to be really, really bad at caching resolution failures or remembering that when they asked for resolution that they didn't get any answer. The graph there on the right is from the presentation to this working group at IETF 113. And there's more supporting data there, so you can go look at that if you want to. But this graph in particular was from the Facebook outage of last year, where we saw a huge increase in query traffic to the ComNet name servers during that outage. So the goal of this draft is really to strengthen the requirements around caching resolution failures and avoid these sorts of unnecessary repeated queries. So there's a little definition in the draft that says a DNS resolution failure occurs when none of the servers available to a resolver provide any useful response for a particular name, type, and class. So just to be clear, we're not talking about a timeout at one of the name servers available. We're talking about timeouts, say, from all of the name servers available, or NX domain, or not NX domain, refused from all of the name servers available, something like that. So next slide. So since the last version, this is probably the most significant change where some of the requirements have been rephrased. Previously, there was language in the draft that said a resolution failure must be cached against a specific query tuple of name, type, and class, and server IP address. And now that requirement is changed quite a bit, where it just says that a resolver must have a cache for resolution failures. And the purpose of the cache is to eliminate repeated queries that cannot be resolved. So it doesn't really, it doesn't say it has to be cached by tuple. That's now sort of an implementation dependent detail. Folks can choose how to do that however they want, and provide some examples of reasons why you might want to do it by tuple or might want to do it by server IP address alone, for example. Next. There's also some new text about how resolvers should protect themselves from possible attacks. So since there's a requirement to cache resolution failures, that sort of introduces a new security risk where an attacker could try to exhaust this cache, send lots of specific queries designed to fill up this new type of cache. And of course, resolvers need to protect themselves and can limit the resources they devote to such a resolution failure cache. Next. There's some text in the draft about timing, and this is really unchanged since the last version. There was a little bit of discussion about this, but what the draft currently says is that resolution failures must be cached for at least 5 seconds. And the justification for this is that this is the amount of time that a user could reasonably be expected to wait to retry or something like that. There's a should level requirement that the resolver should use an exponential backoff in the amount of time that it caches these sorts of things. So, 5 seconds to start, increase, and so on, but no longer than 5 minutes. And the 5 minutes is matches language in RFC 2308. Next. And so lastly, this is kind of a new thing that we would like discussion on. So some resolver implementations would have different caches based on EDNS client subnet values, and sort of open for discussion whether or not resolution failure caching should ignore EDNS client subnet, or if partitioning the cache by that client subnet value would be appropriate or a good thing to do. So I think our opinion is that should be independent of EDNS client subnet, but would like to hear what other people think about that. And that's it.
Thank you, Dwayne. In the queue, Peter Thomassen.
Yes, hi, Peter Thomassen. I think like a few slides earlier, you showed that the partitioning of the cache should be up to the implementers, whether it would be queue name or IP address or whatever. And now this proposal seems to contradict that.
A little bit, yeah.
Yeah, and so the question is, why wouldn't you just leave it up to the implementers if they think it's a good idea or not?
Yeah, that's a fair question. I think the argument I would make is that if there's an implementation that normally has separate caches based on EDNS client subnet, that can really sort of blow up the size of the cache, and so there may be thousands of different subnet values, which would mean that now the resolver is emitting maybe thousands of more times queries than it needs to, right? So if you're allowed to emit one query per subnet value per some amount of time, then that's a lot of traffic still.
So then perhaps that concern should go into this protect the self section.
Yeah.
Peter Gordinik. Dwayne, thanks for doing that work. Also to your colleagues. There's one minor thing. The security considerations section talks about resource exhaustion by deliberately asking for domains or queue names resulting in certain failures. Now, given that most of these resolution failures aren't authenticated, there's probably also an attack vector in forging some of those responses. Is that something you would consider for adding to that discussion? It might not be catastrophic, but it's a window of opportunity as well.
Sure. Yeah. Be happy to add something like that.
Thank you.
No, Akamai, I sort of would agree that it would be great if we could ignore EDNS client subnet, but a lot of implementation sort of for this would be hard. And we've seen in the wild that kind of depending on what you give the authority, sometimes they answer, sometimes they don't. So it would make the positive resolution worse, I guess.
So, okay. So you would vote for not saying anything about this and just leaving it up to the implementation to do how they want?
Yeah, I would leave it up to the implementation.
Okay. That was the cue.
All right.
Okay, thank you, Dwayne.
Thank you.
Yeah. Up next is I think Philip with right. There we are. Yeah. Okay, Philip Homer.
Hi. My name is Philip Homberg. I did this work with Willem Torup, so if later you have questions, find either of us. And this is basically about trying to make complexity of a stub resolver a bit more manageable while still letting the stub resolver be in control. Next slide. So this is when life was simple. Stub resolver sends a query just over port 53 and then hopefully gets an answer back. But then, of course, when most of the traffic on the internet became encrypted, having a stub resolver send queries in plain text is not so great anymore. So the IETF took it upon itself to create ways to solve that. Next slide. And then we got this, because one option is fine, but lots of options is always better. So we got DNS over TLS, then people wanted DNS over HTTP, but HTTP is actually at the moment sort of two protocols, HTTP2 and HTTP3, and then there's a separate DNS over QUIC, and then you can also create nested implementations, and you get oblivious DOH. So complexity for a stub resolver is getting completely out of hand. Next slide, please.
Okay. Sorry. Sorry, no, it's jumping ahead, and I think you want to have this slide. I don't know.
Well, this. The next one after this. Yeah,
there
okay,
it is.
bit
Yeah.
of background. We were working on a library called Connect by Name, and the idea is you put in a name and out comes a TLS collection, and it does all the happy eyeballs and Dane and whatever, simplifying the life of the application. And on top of the get DNS library that we have, and just doing all of the DNS parts right sort of cost what we wanted to change and get DNS to completely explode, because a lot of this stuff is recursive. If you connect to DOH, then you could also do Dane and whatever. So we were looking for ways to simplify it. Next slide. And we also noticed, like sort of in general with this model, there's quite a few stub resolvers out there. Are they going to implement all of these different transports? What if they don't? UDP to port 53 has basically no state. If I run ping and it has to set up a DRH connection to look up an IP, a name, and then tear it down immediately, that costs a lot of extra resources. Resources also show up on a recursive resolver, and in general, you can expect latency and stuff like that. So next slide, please. There's of course an obvious way to solve that, and that is just introduce a local proxy, and then the proxy can maintain those connections for a longer period of time, so it becomes more efficient. And there's plenty of those proxies already around. There's a lot of people who have a local unbound. There's Stubby, more designed as a proxy. There's DNS mask, has been around for a long time. There's a system D, resolve D, that tries to do similar things. Next slide, please. But the problem there is that the application now is talking to a complete black box. It's like, well, What if the application would really insist on having some sort of private collection, privacy preserving collection to a recursive resolver? If you talk to a local proxy, you just don't know. Maybe an application has very specific desires, like it really wants to have DOH connections to a specific public resolver or something like that. What kind of feedback do you get from the proxy if it fails? I mean, you just get a serve fail usually, I guess, if the connection to the upstream recursive resolver fails. And also for diagnostic tools, if your DIC or drill or whatever goes directly out on the internet and the applications go through a proxy, then it creates a mismatch. If your diagnostic tools go always through the proxy, then you lack visibility. Next slide, please. So we came up with this as a solution, and that is the stub resolver includes this option in a request when it sends it to the local proxy. And basically this option can describe what the stub resolver would like to get from the upstream connection to the recursive resolver. And it consists of a number of sections. There's first a set of bits, which basically specify what kind of encryption and authentication you want, whether there's a specific desire to have or exclude certain upstream transports. If an application wants to be more specific, it could list IP addresses for upstream resolvers. If you want to have any kind of authenticated connection, then you need to have a name. If, for example, you want to do DOE, then you want to have a DOE path, so that can be put in the SVC parameters as well as a port or ALPNs. And finally, on devices where outgoing interface really matters, like for example on a phone, if an application is aware of interfaces, then it could also put in an interface name. But the basic idea is that an application is not required to put anything in. I mean, if you just send this option with all bits clear, then you basically tell the proxy will do whatever you want. If you just said, well, I need authenticated connection, then the proxy should figure out a way to give you an authenticated connection or report a failure if it cannot do that. Next slide. The key design thing of this is it's stateless. It sort of mimics the original DNS to port 53 setup. So we send the same proxy option in every request and then assume that the proxy will do something clever to avoid having some sort of state between the local proxy and the stub. We want to maximize control given to the application. Not saying that all applications have to use it, but if they want to use it, then it should be there. Of course, for stub resolvers, the benefit of moving to this model would be that there's a way bigger potential for caching, certainly for short-lived applications. It also introduces an opportunity to implement local policies in the proxy, instead of, well, trying to figure out whatever stub resolver your application has and then try to do something for that. The next bullet item is formulated a bit sloppy here. The idea is that the proxy just forwards stuff from an upstream recursive resolver and is not required to do any additional DNSSEC validation. Basically to say, well, either you do it in the application itself or you leave it to a recursive resolver. But if the proxy would use, for example, Dane or something like that, then of course part of Dane is that you should do that you need to do the DNSSEC validation, but it only does that for internal stuff, not as a server to the user. And we implemented this, not completely, but most of it in a branch of getDNS if people want to play with it. Next slide, please. Thinking about this, if you have sort of a current proxy, then it's quite possible that the current proxies blindly forward EDNS 0 options. And then if you would end up with a situation that some recursive resolver in the network would implement this proxy control option, which is not ruled out, then you could have the situation that the stub resolver thinks it's talking to a local proxy when in fact traffic is just forwarded unencrypted. So there's a separate option that's basically a way to communicate between the stub resolver and the proxy, and then the proxy basically tells the stub resolver what sort of network source address did I get this request from. And I mean, if a stub resolver is very privacy sensitive, then it should say, well, if this is not host local, then just drop it because something is wrong. But if you're more lenient, then you could say, well, if it's still link local and I trust my local link, then I'm going to allow it. So it's one piece of puzzle that you need for the stub resolver to verify that the whole thing is really contained. And then the next thing, next slide, please. This is basically a convenience thing that might need to a separate document or something like that, is that if an application or a stub wants to do DNSSEC validation, and you want to sort of be guaranteed that there's a fallback trust anchor, then it would be nice if your local proxy can just cache the IANA signed trust anchor, DNSSEC trust anchors, and return that. So there's an extra option that basically says, well, please give me this stuff. If you already have a local trust anchor, then you don't need it, but applications need a fallback, and it would be bad if stub resolvers then have to set up HTTPS connections to IANA and stuff like that. So that's the three different options. Next slide, please. So the question is, do people find this useful? Would they like this working group to work on it, or any other kind of feedback or questions?
Thank you, Philip. Last IETF, the author sent the document to the ADD group that was discussed there, but was out of charter. So the different DNS working group chairs discussed this, where to present it or where should it land. We sent an email to the mailing list, to the DNSOP mailing list, with this question actually. And that's also why we scheduled this presentation here. We would like to hear the feedback from the working group. Ralph, please go ahead.
Yeah, Ralph Akamai. So you confused me a bit because when I read the document, I thought I wasn't clear that it was local only. Then you said in the talk it was local only, but then you could extend it. So what is the scope now? Because there are probably different kind of considerations when you have it.
So the scope of the draft is the communication between a stub resolver and a local proxy. But for example, at the moment, lots of people use Unbound as some sort of local resolver, which could be extended to support this option.
So but it is communication on a machine between two programs.
Yeah, yeah.
And you need to change pretty much both programs for stuff to work.
Yeah, definitely.
So wouldn't it be easier to do direct an API like GetDNS for doing that stuff? Just
so we're looking at doing inter-process communication within the host in a way that fits within the DNS model. So there's, I think that's.
But the actual problem is name resolution, and
so it's, right. Yeah. But the thing is, the alternative of doing it is, for example, talk over dbus. And do something like that. And then it sort of becomes completely outside the DNS community to design anything on how that works. So this is an attempt, like, can we structure this part of communication that is definitely happening in the real world in a way that sort of we can have a say on it instead of leaving it to the random implementer of host operating system.
Okay, I mean, I just found on a machine it better to do something with an API, and for going off the machine, we have, that's probably why it comes out of ADD, DNR, and DDR to make secure connections from applications to resolvers, right?
So those are protocols between, in this model, that would be running between the local proxy and the recursive resolver, whereas this would be specific for a stub resolver and a local to reduce the complexity of the stub resolver, because otherwise the stub resolver would have to implement all of the ADD protocols, creating more complexity.
Yeah, I mean, if you could use APIs, let's see.
Thank you. Victor, please go ahead. Sorry, Victor, you're on.
Hi, can you hear me? The Dane mode that's described in the draft is either no mention of Dane or Dane is mandatory, or PKIX no mention or mandatory. And it seems to me that putting the knowledge in the application of which of these will or will not work is fragile. An application doesn't necessarily know which authentication mechanisms will or won't be available to a particular destination. One of the great ways in which Dane works is something called opportunistic Dane, which is use it when there are TLSA records and don't use it when there aren't. So use Dane when possible. That's not covered in the draft.
Yes, because if you set both bits to 0, then it should do exactly that. So the model should be that sort of everything can be clear, and then it's up to the proxy to basically do the right thing. But if an application has specific knowledge or desire, then an application can override that and say, well, this is now mandatory because I want it. For whatever.
Is the proxy expected to do Dane when TLSA records are published? There was no language about that at all.
It's expected to do Dane, yes. So it's expected to exactly do a Dane lookup, see whether that would work or not, and then use the information. Yeah. Of course, if the language is not clear, then that can be added as a more strict requirement. But yeah, it's definitely expected to do that.
Okay. Thank you. Benjamin?
Hi. So I want to focus on something I just heard you say at the end. I feel like was kind of crucial, right? That this isn't formulated as an API because the IETF doesn't standardize APIs, and so the only way we can insert ourselves into this process and provide our proposal for how the system works is to structure our solution in the form of a protocol. And I don't know if that's exactly true. The IETF has started to dabble in API definitions, but whether or not it's true, it doesn't strike me as a good reason to structure it this way. I think that what we are describing here is something that's really most naturally characterized as an API. And if the IETF hasn't traditionally been very involved in API definitions, I think that's for a good reason, which is that those definitions have to evolve pretty fast, and the requirements aren't always so clear up front. In this particular case, I don't think that the specific behavior that's laid out here would precisely work on, for example, any of the major consumer operating systems or for use by any of the major consumer browsers. Those all have very detailed and evolving requirements for how they do their DNS lookups, for what security requirements they expect, etc. So I think that if you actually look at the market for this, I think it's sort of not there. And instead, we do need to figure out a richer API for name resolution for essentially the longer tail of applications who aren't willing to deeply customize their DNS behavior, but also aren't willing to be stuck on getAtterInfo forever. But I don't think the answer is to take all of the metadata about how you want the request to be processed and bundle it into the request itself. In particular, I think that there's a layering violation here where the client in this case doesn't have any clear signal as to whether it's talking to a DNS proxy that is aware of this until after the query has already been issued. It only finds out from the response whether its requests were met. That's a kind of an upside down design to me. I would much rather say, okay, we're going to define a new interaction model, ideally an API in a platform relevant format. But even if it were an IPC, I would still say this is or an RPC. I would say this is a new protocol being spoken between a new interesting pair of parties, one of which is not quite a stub resolver, but it's more like a smart forwarder. But maybe it's a steerable smart forwarder. The client can actually tell it where it wants queries to go. So I think there's a lot of question marks about what we really ought to do here.
So, two remarks. One is, it seems that at the moment there is almost nothing to allow sort of an application to talk to a local proxy through an API, or at least I'm not aware of anything that works on more than one platform. The second part is that the draft specifically has a probing query to make sure that the application doesn't leak any privacy sensitive DNS query name, but can still probe whether this local proxy that supports this draft is available. So in that sense, the mechanism to interrogate the option, the capabilities of the local proxy is taken care of.
Sure. We're running a little bit behind time, so the further discussion can go to the list. Are you sure, Warren? Okay, thank you. And I guess Peter is next.
Yep.
Okay. So I'm going to give a quick update on the draft that I wrote on mandating consistency checks when processing CDS or CSync records. We talked about this in Philadelphia in July and got some feedback, which is not incorporated. Yeah, so this is a quick talk, and the next one will also be mine, which I perhaps will borrow a minute or two from this one. Next. Yeah, so this is mainly for documentation for people who will look it up later when they download the slides. So everybody probably knows CDS records are used by the child to tell the parent which are the future DS records it desires. It's good for rollovers and so on and so forth, and the child publishes it and the parent can digest it. And similarly for CSync, the child can indicate what other stuff should be updated, like NS records or glue. The finding is that the RFCs about these record types don't specify how the parent should be doing the polling. And the simple implementation would be to just ask a trusted validating resolver what the CDS record at a child, for example, is. And if you do that, you end up asking only one authoritative server, which may be giving you one response. And if you ask another time, or I don't know, in another microsecond, you may be asking another authoritative server, which might be giving a different answer. And there is no way to decide what's the right one. And the specifications so far don't consider this problem. So let's look into what can possibly go wrong with this. Next. So there's mainly two scenarios. One is the multi-homing scenario, which gets more interesting if you add DNSSEC, then it's called multi-signer. So consider you have two providers which both host a zone and they sign it independently each other announcing their keys. Yeah, so both providers announcing each other's and their own keys. Now, one of them does a key role and accordingly updates the CDS records for with their updated keys. In that case, when they do that and they forget to include the other provider's keys, which may easily happen when you update the CDS records with your own new stuff, and the parent ends up querying this, it may happen that the other provider gets thrown out of the DS record set, which breaks the chain of trust and breaks the solution. And similarly, with NS updates via CSync, you can get the same kind of problem and remove the other provider's NS records accidentally. So that also breaks the multi-signer setup and the multi-homing setup. It doesn't necessarily mean the validation breaks or that resolution breaks, but it does break the multi-redundancy promise that you have in a multi-homing setup usually. Next. And similarly, when you do a provider change without turning DNSSEC off, you have to do a multi-signer period. So you onboard a new provider and then offboard the first one. And that also involves multiple steps with DS record and NS record updates. So particularly, you have to prepare the DS records for the new provider first and only then add the new provider to the NS record set, and at that point the new provider's CDS records become visible and they haven't been tested before. So if the new provider isn't aware that this is even a multi-signer setup, they may not have included the old provider's stuff into their CDS record set. And then the parent might end up digesting that stuff and throwing the old provider's DS records out of the delegation, although it is still in the NS record set. And that breaks the things too. So this is kind of a special case of the multi-signer thing. So to fix this, let's look at the next and I think final slide. These problems can be mitigated if the parent is a bit more careful and if you have a policy that whenever you use CDS or CDNS key or CSync records as a parent for doing this kind of scanning, you should check whether things are consistent across all name servers in the delegation. You may disregard unresponsive name servers, but otherwise, if you discover an inconsistency, you must abort and not change the delegation, and you can do it again tomorrow, or you can retry after 5 minutes or whatever your backoff policy is. But that would solve that problem. And if multi-signer deployments at some point get more prominent, I would expect these things to happen unless care is taken. So I think we should clarify to people who have these scanning implementations how it would be done correctly. And if someone discovers an implementation that only does one query to one name server, you could easily say, look at this document and you're not doing it right. So this is what I think about it. And I was going to ask the working group if you think this is reasonable, if it should be moved forward, and so on and so forth.
Okay. Thank you. Wes.
Thank you, Wes Herdeker, USC-ISI, no hats. Actually, hat of the CSync author document. I support this because I actually think I wanted to do something like this back when I published it, but there's some pushback. So if you read the CSync document, in particular section 4.2, it says you have to take the most recent SOA. So there is some notion of how to make sure that, even if things are inconsistent, you still get the most recent up-to-date record and things like that. The problem is that in some deployments, my recollection from the discussion is there may be some complexity and you actually want to point at a hidden server, which is actually what this document also talks about in section 4.2. It says, scanners may be, or registrars might be configurable to say, hey, go look somewhere else and things like that. So I'd read that section just to see, what it falls in. But otherwise, I like the idea of mandating checking everything.
Okay, so you said CSync RFC section 4.2? Okay, I'll read that.
So I also support this. There were a couple of things that, maybe in regards to what Wes said, if you kind of ask all servers, you still might not have asked all server because there's Anycast and all the other stuff behind that. Maybe it might be good to have some text around that in the document. And then what is the reasoning behind kind of if servers are not responding to discount them rather than doing some sort of retry?
Okay, so two things regarding your first point about various Anycast nodes. I think the important policy is to ask all providers involved, and you can achieve that by asking one node of each name server host name. So I think that's why that's okay. And then the second way to disregard unresponsive name servers. So sometimes there's maintenance, but more importantly, from some corners of the topology, some stuff may just be unreachable because of routing issues. And you would otherwise never have the ability to do an actual update if you take that as a blocking failure. I don't feel very strongly, and it wasn't in the draft originally, but at the last IETF it was proposed to add it in. I think it was Victor, so perhaps Victor can start the battle.
Okay, I mean, I just found it weird because, I mean, that's obviously has an attack vector to it.
Yeah, I don't feel strongly about it. So whatever the working group feels like.
Paul Wouters speaking as one of the authors of the CDS record. I just skimmed my RFCs, like, did we really not say anything about this? And we didn't. So yes, please do this work. This is our bug. I'm sorry.
It's not a fault. Back then there was no multi-signer.
Victor, you're on.
Allowing name servers to be unreachable. My concern was about hidden masters, and also about being able to remove name servers that have died and aren't going to come back. Right? When your name server is permanently decommissioned, you want to be able to still make updates, and it's presently listed. So, what are you going to do?
Should I add these reasonings to the draft? I mean, I said unreachable corners of the internet, and you said phasing out name servers and all of that. Do you think that's important, or do we just, I mean, it's important, but do you think it's important for the draft, or should we just specify the protocol without justification? I don't know how it's handled usually.
I don't have strong opinions about how to say it.
Okay, thank you, Peter. Just wrapping up, there has also been good discussion on the mailing list in July, August. There's a good feedback from the room. We'll schedule a working group adoption call later, and we coordinate it with you. Okay, next presentation, also by Peter. This one.
All right. So it's Peter Thomason. Yeah, so in the past few years, multi-signing scenarios have been discussed in various places. And I was sometimes part of the discussion, and I noticed that the way that the key exchange that's necessary between the participating providers hasn't been discussed on a protocol level so far, or well, like there's no automatable recipe for it, essentially. It's not really protocol change. And I just wanted to talk about that and put it out there to the group, how that could be addressed. Again, I don't feel very strongly, it's just an idea. I don't know if anyone needs a solution even. Maybe people like doing things manually. But so let's just take a look at it and then we can discuss or do whatever. So next slide. So this is a bit of a messy slide, but I'll walk you through it. So to look at what's needed for the key exchange, it's interesting to investigate how the DNS resolution works if you have a multi-signer setup. And let's say you're asking for some record of interest, let's say an A record, and actually you will need two separate queries. One is for the A record, which gets you the response and also the signature, and the other is for the DNS key that you need for validation. And a resolver might end up sending these two queries to two different name server host names. And in a multi-signer setup, they might be operated by two different providers. And so the DNS key record set is not necessarily delivered by the party who also gave you the signature. So to make that work and to keep it that way that resolvers don't need to be aware of any of this multi-signer stuff, you need to make sure that the DNS key responses include all the keys that a validator may need to do the validation, regardless of whether the record of interest is delivered by the same provider or not. So the interesting question here is what exactly needs to be included in the DNS key record set. And it turns out, of course, it works if you just include all of the DNS keys of all providers. So you just take the global union or something like that. But turns out you don't need that. It actually depends on the queue type. Because if you are looking for the DNS key only, if that's the record of interest, then the signature will always be in the same response as the DNS key. So it will always be done with a key that is part of the DNS key record set you get as a response. So it's actually just a one provider problem in the DNS key record set. So to validate DNS key record responses, you only need the KSKs of that provider, not of the other providers. Yes, for everything else, let's say, for example, for an A record, it may be that the signature is delivered by a provider that's different from the DNS key delivery provider, as I said earlier, because then you really have two different queries. And then you need the other provider's ZSKs, right? Because you don't know ahead of time which name server hostname belongs to who. So forget all about that. The summary of that is, or the bottom line is, the DNS key record set that everybody has to deliver is at least the local DNS keys of that provider who's responding, plus the other provider's ZSKs. So anyone who's sending a response needs to have imported the other provider's ZSKs, but not necessarily the KSKs. And then very similarly for CDS and CDNS key records, if you want to use that, you also have to serve the union of all the providers' KSK type DNS keys, because otherwise things wouldn't work out with the previous draft where you require consistency. So next. So let's look at what the additional requirements would be beyond what are the keys you need. So we just learned that providers need to discover each other's KSKs and include them in the CDS kind of records, and to learn each other's ZSKs and announce them in the DNS key record sets. And all of that in principle has been described in Ulrich Wisser's DNS automation draft, I think together with Schumann. And actually, the link is outdated. It's been adopted already, but the draft doesn't specify how to do it in a technical way. And there are a few questions to answer. For example, one is which channel do you use? And another is how do you decide whether a key that you observe at another provider's DNS key record set that you want to import, if that is actually a KSK or also used for signing of other records, in which case it's a ZSK or CSK. And that's hard to tell because you don't know if a KSK like signs that other one record that you don't see from the outside. And then also, if you have three providers, for example, just for illustration, let's say provider A, B, and C, everybody has imported each other's stuff, and then provider B obsoletes the key that they phase out. It'll have been imported by A and B, right? So how should A, for example, know that they should remove this key because B has phased it out, although it's still visible in C, so it could be C's key, A doesn't know. And that kind of inference doesn't work if you just look at the DNS key record set in the child. So you get these orphaned keys if you only try to infer from what you see at the apex. So you need something else. And that's something else. What properties would you like? So one property would be it should be in-band. I mean, it doesn't need to. We can use REST APIs or whatever, but perhaps you can make it work in-band. Would be nice if it is authenticated. And because of the how to distinguish different kinds of keys problem that I just mentioned, it would be nice if somehow it would be explicit about these things. Next. So there's two proposals. One is for how to do the key exchange, and the other is for when to do it, how to trigger it. The bootstrapping draft has a signaling mechanism, how the DNS provider and name server operators can make authenticated announcements of stuff about their domains that they host. It's used in the bootstrapping draft to make an initial statement about what the DS record set should be before there is a chain of trust. And there is a label in the beginning of the signaling owner names in this draft that is the signaling type. And we can introduce a new one, like for example, _multi. And we can use that signaling mechanism to have an authenticated signaling path between the different DNS operators who participate in a DNS multi-signer scenario. And the idea is that under these signaling records, each provider would announce their own keys for which they control the private part, so no union, and then all the other ones could look at that and collect whatever they find and import it into their local stuff. That requires the host names of the name server, no, incorrect, the zones in which the name server host names live to be secure, because otherwise you can't do the DNSSEC validation of whatever is published there. So it's the same requirement as in the bootstrapping draft. The idea is to do it as shown at the bottom of this slide. So let's say you're provider.net and you want to make an announcement to your multi-signer peers about the domain example.co.uk. Then you would assemble the name as it's shown here, _multi.example.co.uk, _signal. Whatever the name server host name is. And on this name, which is not an Apex name, so it's a subdomain necessarily, you can't have a delegation there. You publish CDS and CDNS key records and put your own case there. And you publish a DNS key record set which has your ZS case. Of course, you would have to update the language of the other RFCs who define those record types to only live at the Apex. And then if you have that, you have an authenticated signaling mechanism, and the other providers can query that stuff and import things. That's the basic idea. It kind of sounds complicated, but actually boils down to just having providers publish a copy of their own records under these names. Next slide. The question is then, how do you trigger this? How does a provider know that the other ones even exist? And when does an import have to happen? So if you consider, for example, the beginning of a multi-signer setup, initially the new provider is not yet in the name server record set. And before you can add the provider, you have to set up the DNSSEC configuration. So you can't do it based on the NS record set because it's not yet there. You can't find the new provider yet. The proposal for discovery is that we introduce a new record type. I have called it tentatively CNS, and it could hold the prospective name server host names in the final state after the transition has happened. That's analogous to how CDS records hold the prospective DS records. And the idea is that when the zone owner has provisioned the zone at the old provider and also the new provider and synchronized all the contents like A records or whatever, then when everything is in order, they add a CNS record set, which is the union of name server host names. So it would have the old and the new name server host names. And when a DNS operator discovers that that has been created, they can look at it and see, oh, okay, so these are my host names, and then the other three are from the other provider, and then they can go ahead and determine what the signaling names would be from the previous slide and import stuff. This also works for triggering a rollover synchronization. So for example, when you have done the multi-signer setup, you would of course remove this CNS stuff again because you don't need it anymore. And then when one provider does a rollover, the zone owner can trigger a synchronization or resynchronization of keys between multi-signer peers by recreating this CNS record set. And then they go and do the queries and collect. Yeah. So that's the idea for the trigger. I don't care about what the name of the record type would be. I called it CNS because it lives on the child side, just like CDS and csync, and it conveys configuration, although not to the parent, but to the peers. And that's why I thought CNS would be intuitive, but I know that some people at least feel differently. Some people have told me. So whatever, I just wanted to include the concern here. We can change it, but I think it's neat. There's two more slides. The next slide has an example workflow. So let's say you have example.co.uk and you are provider A. I mean, you are not provider A, but that's the current setup, and ns1.provider.a.net. And you want to onboard a second provider into the multi-signer scenario. The first thing to do is that the domain owner creates a zone at the second provider B, and you know, provisions all the A records and whatever the zone contents are. And then when that's in order, the domain owner creates the CNS record set, which is a joint set of name server host names at both providers. They both observe this, and then provider B, for example, would do whatever, like _multi, the zone name .signal. And then the other provider's host names, which are taken from the CNS record set, query DNS key and CDS records, do DNSSEC validation on that because that's signed with the provider A's keys because it's a subdomain of their host name. And then you can do the import. Everybody can observe what's happening because provider B can look at what provider A is publishing at the child's apex. And when everybody has observed convergence, then you can go ahead and update the NS record set to finish the onboarding of the new provider. it's possible to just do that by renaming the CNS record set to the NS record set and overriding that and then do csync, or you can use EPP or whatever you want. It's an orthogonal problem to this one. Yeah, so final slide. The summary of the proposal is that it solves the multi-signer exchange problem in a way that has a few properties that I think are interesting. It's automated, it's authenticated, it's in-band, it's explicit about the KSK versus ZSK question, so there's no guessing involved by the importing party. It's comprehensive in that it covers onboarding and offboarding and key roles, and it's minimal in the sense that it has a signaling mechanism which is necessary, and it has a trigger mechanism which is necessary, but it doesn't add any protocol change. Resolvers don't need to learn anything, and all of that stuff. I'm not implying it's the solution. Maybe there's a better one. Maybe nobody needs a solution. It's just what I came up with, and I would be interested in what people think.
Thank you. Sorry, thank you, Peter. In the queue, Victor, but we have 2 minutes for questions for Q&A, so please be brief.
You haven't talked about ongoing ZSK rollovers from the individual providers. The customer's then not involved in publishing CNS records. They might have removed them, but the operators will still periodically roll their own ZSKs. How's the timing of that managed?
So it appears to me, but I'm not sure if I thought it through fully, that if one of the provider does a ZSK rollover, then it would be unsafe to allow the provider to do that unilaterally. And you always need to have the zone owner approve, kind of, by creating the CNS record and say, okay, that's fine, go ahead and change it. I'm not sure if that's true. Right now it seems to me like that. Now, if you're saying perhaps there is a way of doing it unilaterally, yeah, probably there is, right? Because as far as an operator is in control of their part of the CNS records by doing this signaling stuff, why not let them do it? Yeah, so I know of no method of triggering that synchronization.
I think that's worth discussing because providers will want to roll ZSKs if they're the operator for the customer's own in terms of just making the signing go.
Yeah, it's a good point. Do you have a suggestion? Otherwise,
no, we should discuss it later.
Okay. Thank you.
Yep. Since it's a new draft, we should go ahead and bring the discussion to the mailing list. Looking forward to that.
Yeah.
Thank you.
Thank you.
Thank you.
Okay. Our final presentation for today is Tiru. There we are. Right. Share. Okay.
Good morning, everyone. I'm Thiru. I'm one of the co-authors of the draft. Structured data for filter DNS was presented at the last IETF. Next slide, please. A quick recap. It's the primary purpose of the draft is to assist DNS filter troubleshooting. Next slide. At the last IETF, we got feedback with regard to this draft was how would it interop with RPC servers in case they don't upgrade themselves to support this specification. So we added a section to address that specific comment. Next slide. So RPC servers are the ones which, in case if they do DNS filtering, they would put an NX domain response with clearing the RA bit. In those cases, in case if the client is upgraded to support this specification, but the server is not, it would continue to accept the NX domain response. But let's imagine a case where the server is also upgraded to support this specification. In that case, the client would learn the server's capability using the resinfo resource record type that's being discussed in the ad working group, and I will be presenting that in the ad working group in the next meeting. And then the client includes the ADE option in the pseudo record type to tell that it's capable of understanding the ADE response. So with that, the server knows whether the client is indeed capable of understanding the ADE option or not. So it decides whether to put an NX domain response or send an ADE option where it can now parse the fields that are being sent in the extra text field to help troubleshooting. Next slide. Yeah, I think we've been presenting this draft for quite some time, and we've been addressing all the comments that have been received so far, and we request for working group adoption.
Yeah. Thank you. So the document did have received some feedback from the mailing list. I understand there was also interest from the industry.
Yes.
So are there any comments here in the working group? We also put it on a working or on a chair slide that this document might be up for working group adoption. We will move that to the mailing list and schedule it. We will coordinate it with the authors.
Yeah, we have server implementation of this. I spoke to Apple and Microsoft, and they were interested in this.
Okay.
So,
Thank you. Okay. Thank you. That's it. Thank you, Tiro.
Okay. And that's what we have time for today. Thanks, everybody in the room and out in radio land. And some of these things we'll take to further discussion on the mailing list, and looking forward to seeing folks.
Yeah, thank you. So apologies to Sivan. We don't have enough time to give you the floor, but please, working group, read the updated document. He has a pull request ready. That's the domain verification draft. You want to add something?
And thank you, Tim, for the dog pictures.
So thank you all. Thank you for your participation and contribution to the working group. See you next in Yokohama or online. Bye. Minutes is too short.
Well, I think it would have totally sidetracked it.
That's really time.
Oh, yeah, it's not even kind of. We do APIs now and then.
Yeah.
Yeah. Well, it's not like this is that good. Let me ask Suzanne.